All right, last time we did the law of sines. Today we're going to do the law of cosines. We use law of cosines when we're dealing with a triangle that they're giving us the side, 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 or the side angle side. That's when we want to use our law of cosines to solve. And remember, when we say solve for a triangle, we're looking for all 6 parts. So the 3 angles and the 3 side lengths. It tells us that for the law of cosines, if a triangle, and again, we label that ABC, ABC for the angles in capital letters, and then the side lengths across from that A, I'm going to have a lowercase a, across from the B, I'm going to have a lowercase b, and across from the angle C, I'm going to have a lowercase c. And so our law of cosines is described here as a squared equals b squared plus c squared minus 2bc times cosine of A. What you want to do is match these two right here. So we don't have to just use this for A. We can use it for B or C. These two just need to match. So match the angle on the corresponding side. That means that if we were dealing with side length B, we would just have B squared equals a squared plus c squared minus 2 times a times c times the cosine of capital B. So that would be the law of cosines if we were doing side length B. The difference comes into the corresponding side and angle there. All right, if we use this and we're missing a side, so side angle side, you can use this formula. So we've taken this and we've solved it for the cosine A. That allows you to find the angle a little bit easier. So we're using this first one if we have side angle side. If we solve for the cosine A, that's when we have side, 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 so that we can solve for our angle. Again, you want to match that angle with that side length right there. That's going to be the differences in the equations. When you're solving for the angle, when they give you a side, 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 and you're looking for the angle, you want to find the largest angle first. So make sure you look for that one. And where you're going to find that largest angle is across from the largest side. So that's going to help you find the angle. All right, let's try one of these triangles so you can see how we use this law of sines and cosines. So first thing I want to do is draw my diagram of my triangle and label it. So that's going to be A, B, and C. It says in triangle ABC here, A is 8. So across from angle A, we are going to have an 8. B is 19. So I go to the angle B, and across from that one, there's my 19. And then C is 14. And so this one is a side, side, side. So that's an S, S, S. And it wants us to find the measures of A, B, and C. So it told us here if it was a side angle side, we were going to use this top formula. If it was a side, 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 we would use this bottom formula. So we're going to go ahead and use this bottom formula to find our angles. And again, we want to start with our biggest angle. So that's going to be angle B, because 19 is my biggest side. And so angle B is going to be the largest angle. So that's what we're going to look for. So we do the cosine of B. And so when we used A, that's the one that we were subtracting at the A. So we're going to add the 2 other side lengths. So we don't want to add this one. We want to do 14 squared plus 8 squared. And then minus, and that's where we're going to do the B side. And all of this is over 2 times 14 times 8. Now we're ready to plug this into the calculator. If you want to avoid any order of operation issues, use your alpha y equals to get that numerator over denominator so that you can make it look exactly the way it is on your paper. Let me put that where you can see it better. All right. So here we're going to plug in what we've got there, which is 14 squared plus 8 squared minus 19 squared all over 2 times 8 times 14. So I've got it set up just like the fraction on my paper. I hit enter. It does give it to me in a fraction, which is great. And so we've got cosine B is equal to negative 101 over 224. Now, if you remember when you're solving for the angle, because that's what we're solving for here is angle B, we've got to get rid of this cosine. We do that by taking the inverse. So we are going to do the inverse cosine of that negative 101 over 224. That's going to give me my B. To put that in the calculator, we hit second, and then you're going to hit the cosine key. So second cosine. If you want to save some time by putting that fraction in exactly the way you see it, you can use the arrow key to highlight it, hit enter, and then it will copy and paste it there for you. So that just saves a little bit of time. We hit enter, and there is our angle. Remember, angles, we're going to keep 1 decimal. Side lengths, we're going to keep 2. So this gives us 116.8. There's our first angle. At this point, we've got a couple different choices. We can go to our law of sines if you find that easier. Or you can continue with the law of cosines, whichever one you want. But now that we have one angle, we could go back to that law of sines. Since we're learning law of cosines, I'm going to keep going with that one. So I'm going to go to my next biggest angle here, which would be C. So I get cosine of C is equal to 19 squared plus 14 squared minus, that 14 squared should be at the end there. So we've got 19 squared plus 8 squared minus 14 squared all over 2 times 19 times 8. So we want to keep that corresponding. Across from the C, we have that 14, so that's what's going to go there at the end. And so now we're going to go ahead and put that in our calculator. Remember to hit alpha y equals to get that numerator over denominator. And then we get 19 squared plus 8 squared minus 14 squared over 2 times 19 times 8. And so that gives us 229 over 304. We do our inverse. And so we get our C angle is 41.1 degrees. Again, I kept that 1 decimal because it is a degree. So angles are 1 decimal. All right, for our last angle, angle A, that one I really don't have to do law of sines or cosines because since I already have 2 and we know that a triangle is 180, I just need to take those and subtract them from 180. So I'm going to do 180 minus 116.8 minus 41.1. And so that gives us 22.1 degrees. Now I have all 3 angles and all 3 sides, so that triangle is considered solved. All right, number 2. In this case, they are giving us an angle and 2 sides. There's an angle and then the 2 sides. So I'm going to set up my triangle and I'm going to label it A, B, C. So B is 15, C is 10, and angle A is 115. So we're ready to use our law of cosines here. The reason why we're not using law of sines, if you notice, is that in order to set up that proportion with law of sines, you needed the angle and its corresponding side, and we do not have that. In this case, we have 2 separate sides and the angle. So our next step is to get our side here. So it told us that when we are missing a side, we use this formula right here. So this is the formula I'm going to use. Coincidentally, we're looking for our A, so we're going to use that exact one right there. So here we go. We get A squared is equal to are 15 squared plus 10 squared, so our other two sides, minus 2 times 15 times 10 times the cosine of A, which is 115 degrees. This one's a little bit easier. There's not a big setup on the calculator at all. You can put it in exactly the way you see it. So we're going to get 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115. You do want to make sure you're in degree mode. I'd hate for you to do all this work and then not get it correct because you had it in the wrong mode. So make sure that you've gone to mode and verified that it's in degree. And so that gives us 451.79. So we've got A squared is equal to 451.785. Now, I did round it to put it on my piece of paper there, but I'm not going to round it when I actually try and find the number. So we're going to take the square root because the square root is what's going to get rid of that squared. So I hit second and then the x squared to give me the square root. And I use my arrow key to highlight that top part. That way I'm not using a rounded amount, I'm using the entire amount. I hit enter, and so there it is at 21.26. Remember that we keep 2 decimals for side length, so this is 21.26 centimeters. And so now we have our A side. We do need another angle. We can go ahead and use this now and do sine of law of sines if you want to, or you can continue to use the law of cosines, whichever one you prefer. So today is law of cosines day. I'm going to keep going with the law of cosines. We get cosine of B is equal to 21.26 squared, which is the one we just got. I need the C one as well, so I'm going to do 10 squared minus 15 squared, because that's the one that goes with B. And so remember, that's the one we subtract here. We make sure it's matched. And then all of that is going to be over 2 times 21.26 times 10. We put that in the calculator and do the inverse. So there it is. I put it in my calculator. I hit enter, and then I do the inverse cosine. And we get 39.7 for my angle. So angle B is 39.7 degrees. At this point, you can do, again, another law of sines, or you can do another law of cosines to get the last angle. But the easiest thing to get the angle is to take that 180, subtract the 115, and then subtract the 39.7. And so our last angle, which is C, is 25.3 degrees. And there is that triangle solved. We got all 6 parts. All right, we're going to look at some word problems. This is the harder part, is always getting that word problem information into there. So here goes. A pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? So here is my baseball diamond. My home plate is right here, and then my first base is right here, and it says it is 60 feet from each other. So I know that part is 60. It says that the pitcher's mound is 43 feet from home plate. So 43 here is where the pitcher's mound would be. And we are looking for this distance right here. Now, we do know this is 90 degrees. And so that makes this angle right here 45 degrees if we're cutting it in the middle. So we've got side angle side for this one. Our goal is to find this length right here. And so with our formulas, it told us that if you were looking for the side length, you want to go with this formula. If you're looking for the angle, you want to go with this one. Since we're looking for the side length, I'm going to go ahead and use that formula right there. All right. So the one that is across from the angle, which is the one we're looking for, that's the one that goes on the outside. So I get x squared is equal to 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45. That's what's going to get me our distance there. All I had to do was straight plug in my two sides and my angle that was included there. I put this into the calculator and I get x squared is equal to 1800.33. And then I take the square root, and that's a rounded number. I remember to take the entire thing. And so that gives us 42.43 feet. So as long as you can get the words from the word problem to draw that picture, you should be able to do it because it's just like the ones that we did on the other side. All right, we're going to do one more here. It says a submarine sights a moving target at a distance of 820 meters. A torpedo is fired 171.66 meters ahead of the target and 924 meters from the submarine, as shown below. Find the angle at which the torpedo was fired. So that, they did you a huge favor here by drawing you the picture. That is what we're looking for here, theta. And they gave us side of this triangle. Since we're looking for the angle, we want to use the second formula. So we're going to use this formula here to find the angle. Since theta is the one that we're looking for, we know that cosine of theta is going to be on the outside here. And the one that's going to match this is going to be that one at the end. And it is always the one straight across from that angle. So this is the one that's going to be at the end. So I start by adding my other two sides. 820 squared plus 924 squared minus 171.66 squared. And then 2 times 820 times 924. These are big numbers, but you don't have to worry about that because you have your calculator. So we get cosine of theta. We put it into the calculator just like before. Use that fraction line so that you're avoiding all kinds of order of operation issues. And so here it is on our calculator. We hit enter. And so that gives us our decimal value. And that's the one that we want to take the inverse cosine of. So I'm going to hit second cosine. And I highlight that and hit enter. That way I'm not using a rounded number. I'm using the entire thing. I hit enter and there is our angle, 8.998. We do keep one decimal. So that is going to round to 0, 0. So we get theta is 9 degrees. And this was 0.987. I never wrote that there. So our theta, which is what we're solving for, came out to be 9 degrees. That is the angle at which the torpedo was fired. And so there's some word problems. There's some regular problems to solve those triangles. As you get more comfortable practicing them, you're going to learn those formulas. We'll be giving them to you for the test anyway, but you should get comfortable using them. All right, they're solving those triangles with law of cosines.